Hi, everyone. So just to kind of introduce ourselves, welcome to the site tour of the OSU Frank Stanton Veterinary Spectrum of Care Clinic. It's a little bit of a mouthful. We are over here on the veterinary campus. So we've got the towers looking this way, and right behind us is the building. So just to kind of give you guys some context, this is looking at the towers this way. And then we've got the stadium to the left. And then to turn back our camera around, right behind what we're looking at here is the existing veterinary hospital. So just to give us an introduction, my name is Allie Fomich. I graduated civil engineering OSU 6 months ago from the program here. I've worked for Elford construction for almost 3 years now. And I've been involved in healthcare construction specifically for the last year and a half. Now before that, I did some construction work in highway and estimating. But now I've officially moved to vertical construction and I'm the assistant project manager here. This is my twin brother, Keenan. I'll let him introduce himself as well.
Hi guys, I'm Keenan Fomich, her twin sister. I also graduated about 6 months ago, just in past May. I'm doing construction management for in my home, so residential construction. Before that, I did some engineering work for a subcontractor and also worked for a chemical company and eventually landed my way into construction management and loving every day. So it's been a great experience. Oh, and I was environmental engineering in school. So, yep.
Oh, great. So I'm going to have Keenan go ahead and turn the camera around and we'll give you guys a little overview.
Oops, sorry.
All right. So here's what we're looking at. This is a new build. This started out as a parking lot. That's pretty unique on OSU's campus because most of the time you're building on top of existing buildings. So we have a pretty cool site in that we're able to be pretty isolated. And right now, not just with COVID, but in general, safety with the people around the site is really important. So we've got a pretty cool pocket over here. You can see we're fenced in all the way. And we are just starting to get what's called dried in, which is where we've got the building essentially safe from moisture infiltration, rain. So when you see this purple board up here, that's what that is. That's weather resistant wall sheathing. So just a little bit about this project. It's about 35,000 square feet. It is a spectrum of care veterinary clinic. So we've got a dental suite, we've got a couple surgery suites, we've got exam rooms, observation rooms, and then this interesting component that makes it unique from a lot of places is that it's integrated completely for the students as a learning opportunity. So it's pretty unique and one of the only clinics of its kind. So we're really excited to be a part of that, especially after a few years ago getting to build the current existing veterinary medical center. So it's a really neat partnership for us. We really like working with the college here, and it's exciting after a few short months to be back on campus. So we're just going to go ahead and walk through the building, give you guys some just interesting tidbits. We started in, I think June 1st was our official start date, and this project has 1 year to complete, which is a pretty quick turnaround. Part of that is the Frank Stanton Foundation, which is the building's namesake, has a grant that we need to essentially fulfill by the end of 1 year. So this project is pretty speedy. As you can see, after only a couple months, it is really, really moving. There is an elevator. We've got 2 different stair towers. And then upstairs, we've got a lot of shell space, classroom space, and a conference room. So there's a lot of opportunities for future growth in this building. The architect on this project is Davis Wentz, and we are working pretty closely with them on a daily basis, really, to work through this building. So we'll just go ahead and head in there. Just as a warning, I'll have my mask on. It might be a little harder to hear me, but just to make sure that we're fulfilling all our regulations. So we'll come on in this way. And what we're looking at here, only a short week ago, was completely dug up and trenched for all of our sanitary piping. It was extending around this whole part of the building. And as you can see, it's already been compacted. And eventually this is going to be a parking lot that we'll be paving next spring. Now over here, we've got this concrete pad. Now underneath this concrete pad is what's called a storm tech system. And it's essentially these big orange basins almost. And it's a really kind of a new technology, and it's almost like creating an underground pond. So the reason we've got this concrete pad here is to just provide extra protection. If there were ever to be, a fire truck or something like that sitting on it, we want to make sure there's extra reinforcement. So That's what that concrete pad is for. That will actually get buried and it will look just like over here. And next year we'll be paving that and it'll be ready for parking. So one of the unique challenges in this project is that OSU is anticipating the construction of a new chiller plant or power plant down the street. So because of that, it doesn't really make a lot of sense to install a bunch of permanent utilities. So a lot of our big equipment like the chiller and the boiler are actually temporary. So we're installing them for a few years essentially, but it is an interesting challenge. So once that is built, what they're going to do is come across this parking lot here and tie in to this hydronic piping, which is chilled water that travels underneath the ground. Now, the thing that's kind of unique about this piping, we can see it here coming up out of the garage. These are all of our valves and there'll be an access panel here. Is typically when you're building a chilled water system, you flush it, you clean it, and then you let it operate. And it's constantly operating. So you really don't have to worry about stagnation. Well, we don't really know when this system is going to be operable. So we had to have a few sit-down meetings with the design team, with OSU, with the engineers, and work through how we were going to keep this system isolated and safe with an indefinite period of time without necessarily degrading any of the valves or the seals. So we ended up landing on a nitrogen fill. So this pipe that extends down to this parking lot past that big pile, it's a dead end actually. So it's got, it's filled with nitrogen and it's safe for another couple of years before they tie into it. So a lot of what we're doing here is actually preparation for future work. And that really came out of our relationship with our subcontractor. So our mechanical subcontractor is installing this, and the specs say you just fill it, and he's going, hey, this doesn't really sound right. I want a quality installation. So he brings this issue to us, and we sit, we dive into it, and then we bring in our design team. So that's really a lot of where engineering becomes the focus point in construction, and not necessarily specific to a certain technical application, but the problem solving attitude. And the guys in the field here, guys and girls, they are really true engineers in that they are constantly mastering their problem solving by simply doing it. And it's pretty neat when you get those people in the room with the people who design it on paper. There's some pretty cool things that come out of that. So by no means in construction, in our role, do you have to be the expert on everything, but you always know someone who is. And getting those people in the same room not only solves the problem, but I've gotten exposure to so many things that I really wouldn't have otherwise. So that's just kind of a unique aspect of the problem solving mindset, especially on a very fast-paced job like this. So we can go ahead and head into the building now. So what we're working on right now is all of our MEP roughing, so mechanical, electrical, and plumbing. They have been working on their what's called above ceiling MEPs for a couple weeks now. So all this duct work, all this conduit, all the water piping has been ongoing for a while now. And as you can see, it's very tight. This, to achieve this here with very minimal problem solving in the field, is a result of our BIM team. So not sure if you guys know much about BIM, but it's building information modeling. So essentially we have this entire building and every little piece, pipe, fitting, modeled into this 3D space. So we are able to beforehand detect any clashes that there might be. So this was a really big push to be able to coordinate this building in time to keep up with a very, very fast schedule. So our team and all of our subcontractor BIM designers knocked it out of the park. They had this whole building coordinated in a matter of weeks, which is pretty record breaking. So now when we're out here, we've got our iPads and we can actually view everything that's going to be installed or currently installed and compare it to a 3D reflection of what it is. So that's a really valuable tool, especially in somewhere that's so tight. So another effort of coordination that's really pretty critical in the schedule, as you can see here, we've got this purple board only at the top. So this drywall here is very selectively placed. I want to come over here in areas that would be really hard to put drywall once you've got this ducted. So if you're looking here, to be able to get your hands up there to install on that drywall would be pretty tough. So what that means is when we're just starting this process, every single morning, we're sitting down, the guys that are working out here, and saying, all right, where are you going next? Where's your duct going? You need to put drywall here. And we're essentially coordinating this sequencing effort to snake around the building in a way that makes the most sense for the installation. So as easy as it sounds, you obviously start high and you move down. So the lowest system should be installed last. But when you're waiting on answers from the design team, maybe you've got some conflicts, it starts to get a little convoluted. So that's where a lot of that problem solving comes into play. So what we can see here, we've got quite a bit of copper piping up here. We've got our domestic water is what that is, as well as quite a bit of duct work. Where we are right now, almost directly above us is where the air handlers are going to sit. So that's all of our mechanical, our big heavy equipment. And those pieces of equipment actually have to be brought into the building with a crane. They're really heavy and they're really big. So we have to design into the building a leave out so that essentially we can leave out part of the building to be able to put the air handler in from the side and close it back up. So that coordination is really not something that's planned as a part of the design. It's something that we're working with our contractors to help problem solve and coordinate to make sure that they can get their equipment in where they need it. So this building is structural steel. It's actually a pretty straightforward structural steel design in that it's not an addition onto any existing buildings, and it's really just a rectangle. Our steel erection went very quickly, but I do want to show you guys kind of a unique feature of this structural aspect of this building. So over here on this side of the building, we can see there's this big beam that extends all the way across both sides of this building. Now, it doesn't necessarily look like anything unique, but what we're seeing here is actually a transfer of force. So we've got this plate here. Now, this plate is what holds up all of the brick that's going up here. So this is the angle that's supporting all of the brick that heads up the building. Now this, rather than going straight down and being supported by the concrete foundation, it actually transfers the force into this beam and then heads down to the piers. And the piers are actually really the only place where we're seeing a lot of strength and capacity. This concrete foundation, or this slab on grade as it's called, really doesn't offer a lot in terms of strength. And a lot of times that is actually how it's designed, is to be really the main structural element for this base here. But we've got this design here that allows the force to be transferred pretty uniquely down to these piers across the building. So like I said earlier, there is a surgery suite in this hospital, and a surgery suite comes with its own unique challenges. There are a lot of very specific requirements that come with building a surgery suite. It's a very sterile environment, and that needs to start at the very beginning, not just when we hand it over. So a big part of that is making sure that our ductwork is remaining sealed. So when you look up, I'm not sure if I see an example, but when you look up, you'll see the ends of the duct are sealed. And that's to protect from construction debris getting inside the ductwork so that when the project finishes, we're not continuing to push through debris through the system. Now over here, we are in these two OR suites, the surgery suites. So one thing that's pretty unique about the surgery suites is that there are very, very strict requirements regarding airflow and the differential pressure in the rooms. So if we come over here, what we see is this right here. What we're looking at is a part of the laminar flow system. So the way, if you've taken fluids, you probably know what this is. we're essentially trying to maintain laminar flow of the air at all times in these rings. So the air will come out from a laminar flow device in the ceiling that's not quite in yet. It's going to come down, again, no turbulent flow. That's very critical because of the particulates that might be in that environment. They will flow in a very distinct direction towards this and that one over there. And those are our returns. So the air gets pulled into there. So essentially, we're creating a constant environment of fresh air flowing in one direction. The other really critical piece of this is that there is constantly positive pressure in this room. So with the positive pressure differential, nothing is infiltrating this extremely sterile environment. So we'll have pressure sensors in certain areas that allow anyone entering the room to verify that the pressure differential is indeed positive, and that by entering the room, they're not pulling microbes or any kind of particulates into the room. So a lot of very unique considerations when it comes to really any kind of healthcare application, but especially if you're talking about a surgery suite, given the requirements for sterility. So now we're going to go ahead and head to the second floor. As I mentioned earlier, it's a lot less dense on the second floor. We've got the shell space, which is really for future use. We've got a big conference room overlooking the towers. We've got our big classroom space that the students will be able to utilize in conjunction with the actual medical treatment down here. And then, of course, we have our mechanical space. So we'll go ahead and go take a look at that now. So here's an example here of making sure that we have sealant over the ductwork. So they will replace that as time goes on and continue to keep it replaced until the very end of the project. So up here, we're on the second floor. As you can see, it feels a little bit bigger. There's a lot less going on up here at the moment. So what we're looking at right now, we've got all these heads coming down here. These are sprinkler flex heads. That's a pretty new standard that OSU allows. This is a pretty significant schedule help because essentially they're able to put in their system and not come back until the ceilings are in, and they can go ahead and set the sprinkler head where it needs to go versus a hard install. So our fire suppression system is complete in this area, for substantially complete as much as it can be. And then what you're seeing here with this white, that's our storm piping coming up from the roof. So our roof was just completed. They're finalizing it tomorrow. So the design has got this sloping, and that's a part of the actual structural steel. So that comes sloping down, comes through these, and goes actually all the way through the building and out. One thing that's pretty tricky sometimes is actually replicating the slopes that you need in real life on the roof, because they actually do that with the insulation buildup. So they use a very specific buildup of insulation that's tapered to achieve that drainage flow. So it's really not all of the structural elements, it's the roof itself that helps achieve that drainage. So here we can see anytime you've got these lines snapped on the ground, that's where they're laying out for their walls. So one of the first things they'll do in this area, this, is they're going to start wall layout. And when you start your wall layout, you're going to be able to see, one, are things lining up the way they're supposed to, and two, understand where your penetrations are coming from, mechanically, electrically, plumbing. So generally speaking, we really don't like to have things exposed, right? We don't want an electrical conduit hanging out in your waiting room. So it's a coordination effort to make sure that we're lining up all of our systems to be within these very small tolerances of the walls themselves. So up here, and it's not just up here, but it's a lot easier to see, there's some holes up here. You can see our fire suppression piping is actually cut through the steel. Now, sometimes you'll see this because there's an oops and they need to fit some fire suppression piping where it should be, but this is actually the design from the beginning. They decided they wanted this building a little bit shorter. That was just a value engineering option that they took. So the way that we decided to remedy that as a team was to reduce space by not having this piping below the steel. So this was all pre-engineered, pre-designed. When they fabricated these beams, they came fabricated with holes in them. It's a really not a very common strategy, but it was something that had to be coordinated pretty heavily. So it worked out well, and now it really earned us, doesn't sound like much, but it earned us a few inches in the building, which is pretty critical as you've seen how crowded it gets down there. So another thing that was pretty interesting is the beams that you see here, they're replicated underneath this concrete slab on deck. So for those of you that may have already taken concrete, you know that, or materials, you know that concrete's a lot heavier when it's wet, a lot heavier. So when they're pouring, they're actually, having to account for a lot more weight than any load this building is going to ever have. So there's kind of this over-design factor where you've got the most weight you ever going to have when you're pouring, and then the rest of its lifetime tends to plateau. So one interesting way that they combat that is the beams that we're standing on right now across these areas, they were actually cambered. So when they were fabricated, they were cambered. So you can picture they're cambered like this. So when they poured, like this. So when they poured, it was so heavy, and this was per design, that it actually uncambered them and brought them back to level. So I think that's just a pretty unique, interesting way to look at how engineering is interacting with your boots on the ground productivity. So it's not just designed for the end space, it's designed for during construction and the end users. And that's where we see a lot more success and we see a lot less problems, is when they're integrating the construction team in the process really early. So we tend to catch a lot more problems when you have the builders giving their input on how it's being built. I suppose we could probably stop for questions. Are there any questions before we continue? Alrighty, well, I think that's all that's up here. We'll talk a little bit about another kind of unique challenge that we've had, and just to speak to the engineering brains a little bit. This is something that piqued my interest very recently. We had one of our subcontractors working on the medical gas piping, which is a copper piping. It has very, very specific requirements because medical gas is generally very highly flammable. It's got a lot of very stringent requirements, especially used in a medical setting. So they came to us saying, hey, we're looking at this installation requirement, and it says that we're supposed to braze all of these certain adapters into a certain valve. And they kind of said, hey, this isn't going to work. This isn't how we do that. And me, being a civil engineer, I do not know what he's talking about right off the bat. So what we do is we come in the trailer, we sit down, and they walk us through every part of it. And they give us what we need to know to be able to raise the question with our engineer. So the issue was essentially that after many years of installing medical gas, they were aware that if you're going to be brazing very close to a copper fitting, it'll actually reach a point where it starts annealing. And that annealing, if you don't know what that is a softening. A lot of times it's done on purpose to increase ductility, but in this case, you do not want ductile fittings on a high pressure medical gas system. So we went back and forth a lot. They felt really strongly, and again, that's part of surrounding yourself and hiring a really strong team, is that you're valuing their experience and their input. So we ended up taking it to OSU, and we've actually submitted a variance for their standards because we feel really strongly that it's not going to produce a quality system if we braze instead of soldering. So that was just kind of an interesting that happened to me the last few weeks, just trying to navigate something that I really haven't learned a lot about, and now that's something I know to look for. So I think that's a really unique part of construction, is that I've been in healthcare now for a little bit, and there's some things that are the same and some things that are not, hospital to hospital. But I can learn about unearthing ancient duct banks, and then over here I can learn about brazing medical gas piping. So surrounding yourself by being in the field like this allows you to really pick up on a lot of things that you can later kind of read about when I put on my engineer's hat and really understand and put into context. So I will say, if you're looking for something that allows you to access your communication skills, your leadership skills, you're always wanting to be learning. Construction's a really great place to do that. I feel like there's not a day where I don't learn something new. Sometimes that's hard, sometimes it's great, but it's pretty unique to be in an environment that is constantly evolving so much. So that's our kind of walkthrough up here. We can go ahead and head back downstairs. So up here, you'll see that there's this one beam that's white. And I believe Dan included the article to talking about this here. We're looking at the plain white side, but on the other side, there's a lot of signatures. So one thing that we like to do when we hit a big milestone, such as completing the structural steel erection, is hold what's called a topping out ceremony. And it's kind of a symbolic lifting of the last beam. So we were able to fit this into our schedule and time it just right. We had this beam selected. We worked with our fabricator to make sure they picked one that was facing the right way and on the right side of the building. And they were more than cooperative because it's an exciting thing to provide for your users. And we had it out there to sign for a few weeks and then had a little celebration outside to show the final lifting of this beam. So there's a lot of neat things that you can do that when your owner, like OSU, the college, is your partner, not just an owner that you're producing a product and leaving. So I found that to be really valuable, especially working where I went to school, is not only do you care about what you're producing, but your user, your owner really, really does. So that was a really cool experience to provide for them. And there are more milestones like that, but that's a pretty unique one because it's so early in the project. And what we're walking on right now, this is a temporary stair tower. You can see it's got plywood around it. That's for safety purposes. It's not the prettiest in the world, but this will later be replaced by an actual fabricated stairwell.
And in case you guys are wondering, it's very fun to walk down with a camera. Not scary at all.
Okay, so one thing that's also a unique challenge with a hospital is that generally speaking, you've got medical equipment that's not being provided by you. The hospitals have their vendors, they have X-ray machines or very specific lab equipment that they're installing. But a lot of that equipment needs mechanical, electrical, plumbing hookups. So a big part of our role is coordinating those decisions, those cut sheets, those pieces of equipment, and getting it to the right people out here to make sure that they can install it correctly. And sometimes what that means is actually retrofitting what's already installed to make it work. So there's really a lot of hands-on engineering that you're seeing on a constant basis. I know when I was in school, I was kind of like, well, if I go into construction, am I really going to get to use this problem-solving technical side of my brain? And to be honest, I really feel like I use it more out here than I do when I'm in the office because, it's this very live effort of making all of this stuff fit. I mean, this is, a pretty amazing, and we're not even done, pretty amazing coordination effort to get all this in. One of the ways that they really helped out themselves with the schedule is our subcontractors decided that they wanted to get a head start on installing all of these hangers. So if you see right here, there's a little red tab hanging out of there. There's, right, this is, yeah. And then all of these here are hangers. So you can see on this ductwork right here, you've got hangers, and that's how they put all of their equipment. So what they do is they put all of those in first, and that allows them to guide their installation. So one way that they were able to really get ahead is before we poured our slab on deck, which is slab on this metal deck here on the second floor where we were standing, is they came through and actually shot hangers through the metal deck, and then they were poured over. So this required a little more coordination and a really big push up front, but it allowed them essentially to start their installation of actual equipment almost immediately following completion of the slab. So we were really excited about that interest in trying to expedite their work and get ahead. And it really allowed us to kind of thin out the number of people that are in this very, very crowded space at any given moment. my last little fun anecdote from this project that's been kind of a challenge is, you look at a parking lot, especially one that's surrounded by some fields, green area. We've got a river right here, and you generally assume that it's pretty safe from existing unknown utilities. But we've actually had quite a bit of trouble with encountering utilities that, not even the utility companies are aware we're here. So an example of that is that over here towards the entrance on the north side of the site, they were doing some hydrovacking, and that's where they basically dig a very small hole and they're able to almost, with water, vacuum out to kind of get a scope in to see what's in the ground without tearing everything up. So that's a tool that our site workers, Mr. Excavator, uses to make sure that they're locating utilities before they really start digging in the ground. So instead of the 50-inch circular storm pipe that was supposed to be over here, they dug it up and it ended up being a 75-inch elliptical pipe. That's really not something that's installed anymore. No one was aware that that particular pipe was in that particular spot. So that's been a pretty big schedule challenge for us. We've had to do some rearranging. So there will be a very big storm detention system over here, just like we saw before with the concrete pad over it. But again, we had to do a lot of shuffling. So, the schedule that you start with really isn't always the schedule you end with. But as long as you're still finishing on the same time and managing everything in between, that's really what matters. So that was a challenge that we brought our civil engineer out of the office and had him come down. We were looking in manholes, trying to problem solve and figure out what we needed to do. And sure enough, we did. And we're excited to be able to get to install it just a little later than we planned. So that's really the tour of this particular project. My other project was the surgery center at OSU East Hospital. So very different. It was an addition as well as a renovation. Very tough. It was a hospital built in the 50s. So a lot of asbestos, a lot of jerry-rigged utilities that were difficult to work around. So as far as doing, a new build, this is a unique experience for me. It's pretty neat to be able to have a little more flexibility and ownership of what you're building versus trying to cater to a renovation. And it is nice that we're able to be isolated over here like I talked about earlier. But I have always wanted to work in construction. I went into civil engineering knowing that I wanted to work in construction. I absolutely love it. My day looks different every day. That's my office every day outside. And I would love if there were maybe a little more exposure during college to construction, because I think sometimes it feels like it's hard to get into, especially at OSU where there's a lot of people that are more, research focused. So that's really my spiel of this site. It's a really exciting project. I'm sure a lot of you are near or on campus and can probably see it going up. So feel free to drive by. We'll be done and operating next June. So are there any questions? I know that was a lot of talking.
Yeah. Hey, Allie and Keaton, this is Bradley. Can you guys hear me all right?
Yeah.
Yep.
I've got a list of questions, so anyone else feel free to jump in. But first of all, that underground retention you guys were talking about, is that ADS?
It is. Yep. ADS Storm Tech.
I got a question about BIM. How, as a project manager, is that something that you're going to see? Do you think that it would be beneficial to be more acclimated to at all? Or is that just something like keep it to the BIM guys?
No, I think it's actually a really big asset. I mean, I really hadn't had any experience with it. And we actually had our BIM coordinator come out here yesterday and show me a lot of the features that I was misusing. So I think that's an asset. I mean, if that is something, if you're looking to go into construction from the general contractor side, that is something that would make you an asset, because I mean, to be able to look in live person what you're supposed to be building before it's built, that really is something that they're looking for. And that's really what we're looking at, is preventative quality control. So a lot of times, if I was able to be more involved because I'm good at it, I would love to. So I don't think it's not very separate. It's not like, here's the BIM, here's your drawings, ready, go. We have a pretty collaborative effort with them, at least at Elford we do. We had actually our BIM team out last Friday to walk the site, really check in on the progress that they've made. And that was pretty rewarding for them to see it in person. But I would say it's not really separate. I think you can make it as involved as you want, but really having it be more integral to your skill set is really puts you at an advantage.
Awesome, thank you. That slab on grade you had there, is that post tension? Why or why not?
Sorry, can you say that one more time?
Sorry.
It got a little quiet.
Was that a post tension slab?
A post tension? No, it was not. So we just got some wire or mesh reinforcement in there with lap joints by 8 inches, I believe. Because again, this isn't, as I showed with that beam earlier, this slab weirdly really isn't holding a lot. So the requirements aren't super stringent.
During that wall layout you were talking about, if you ever do come across a discrepancy or a misalignment or an oops, as you're saying.
I'm sorry. Ray, you might still speak up a little. I'm having trouble hearing you.
Oh, sorry. Can you hear me now?
A little bit louder if you could.
Man, I'm practically screaming now.
Hey, Bradley, you got real quiet all of a sudden. If you want to say it real succinctly, I can repeat it. Because we can hear you fine. I think it's just they're having trouble.
Awesome. Where's it at with those?
You gotta check your list.
You were talking about the wall layouts, Bradley, and if there
was
a discrepancy.
Yes, sorry. I actually jumped one of my questions. That's why I was thrown off. When you find something wrong during the wall layout, how do you address it from that point?
Yeah, so that's a great question, especially relevant right now because we are doing our wall layout. So one of the first things we'll do is we'll have them back check because generally you're pulling dimensions off of something to do that layout. If that still seems to be a bust, then generally we're looking at a design issue. So we've actually had a few of those this week where, maybe this size, we lay it out and we go, like this doesn't quite look right for a door. So they raise the question and we submit what's called an RFI, a request for information. And this is it's technically a contractual correspondence document where we're saying to the design team, hey, we need this clarification. So just yesterday we had one of those where a wall was not actually lined out where it was supposed to be. They laid it out and sometimes it just takes laying it out to say this isn't where it's supposed to go. So thankfully they usually catch that, hopefully, during the layout process. So we submit an RFI, we set up a meeting sometimes, like a quick phone call with the architect and say, hey, this is what we're doing. Now, a couple considerations is this a chase? So as they're piping going through it, that would mean that it really can't move a lot. Or are there restrictions regarding ADA? So a lot of our doorways really can't move or be adjusted at all because of that. So it happens a lot. A lot of times it's really a coordination issue. So, if I've got my plumbing penetration here, but the wall ends up laying out here, that plumbing is probably in the wrong spot. So sometimes that's the way you have to back check. Obviously, it's not the way you want to back check, but it does happen. And I think the biggest thing is raising the question early. And our design team's been really responsive, I would say. As long as you raise it early before they're, tearing up concrete, generally it's a pretty fixable problem if they're just during the layout phase.
That laminar flow device, that was pretty cool. Do you see that used in any other industries outside of healthcare?
I would imagine maybe in very specific manufacturing applications, I would assume. Labs definitely would have that same requirement. I will say, the whole hospital we did, that was the only place we had laminar flows were in the operating room. So I'm not really sure. I bet there are other applications because, you really think about, any kind of environment that you need to be maintained very stable at any given time. That laminar flow device is really just serving as a regulator. So maybe it's not so much that it needs to be sterile, but maybe it needs to be particularly still. So I would be curious to know. I'm not sure if there's a lot of other applications, but I know it is definitely a hallmark of healthcare because you are so concerned, as we've especially seen with COVID, understanding how the airborne pathogens can travel throughout your space.
Awesome. That's all I got. Thank you, guys.
Those were great questions. Thank you.
Out of curiosity, how many RFIs are you guys up to?
115.
Ooh, that's a lot.
Now, to be fair, we don't mess around with RFIs. If there's even a glimmer of uncertainty, we're submitting it. It's a little extra paperwork, but a lot of times that's how you flush out problems, and that's how you get it on paper that this is how we're building it. Because at the end of the day, we're hired to build the design that we're given. So the way this project's structured is the design team is hired by OSU, and we're hired by OSU. So we're actually like parallel partners with the design team. That can be tricky sometimes, but it also means that we actually have a lot more collaborative relationship. So as much as the RFIs can be annoying, they generally are a phone call and allow us to address a problem rather than waiting and having a lot more work for the design team to redesign retroactively.
So you guys just hit a real big milestone getting all that structural steel up. Do you have another sort of big step like that in the works? What does it look like? What's the next big milestone that you guys are headed for?
So our two big milestones were, we've got the slab on grade, then we had the steel, and then the slab on deck. The reason why those are big is because they allow all of this work to start. Our next really big milestone you're kind of hitting right now, and that's being dried in. So when you're dried in, you're essentially isolated from the environment in a way that allows you to protect the work that's on the inside. So if you notice, we had that purple board up high in that priority wall top out. The reason why we had to use that purple board inside is because we put that up before we were dried in. So without a roof, obviously, you can get water in the building, so they had to use moisture-resistant drywall. If they didn't use that, they wouldn't have been able to start that drywall when they did. So there's a lot of little things like that are, again, work up front that saves you time later.
Cool. So getting the whole thing protected from the elements is basically, encasing it. That's what comes next.
Yes. And I would say the next big thing after that, which is hopefully in a few weeks, is, you can see right here, these gray steel angles right here. What's going to sit on that? We've got our metal panel system. We've got brick veneer. And then these openings here are where we have our curtain wall. So our curtain wall, the reason why that's a big milestone is not necessarily because on the outside you look and you see that that's a milestone. It's because, especially right now during COVID, with a lot of our manufacturers, getting that material is a big deal. It's a 12-week lead time, and that's 12 weeks once you get it approved. So it took us about a month to get it approved to begin with. So that's a big milestone just because it's a really complex system. And another unique thing that we have here is the goal of this building aesthetically is to match every single thing across the street at the existing hospital. So we're trying to mimic a few years later with different contractors the exact same building. So I would say the curtain walls really are our biggest next milestone. After that, it's really going to be moving into finishes. So that's your flooring, your drywall, your painting. Well, not drywall, but that should come before your painting. And then starting to get all of our, our outlet boxes, our, any kind of finished item that isn't really the skin and bones. Because one of the things that's true for a lot of OSU projects that I've been a part of, at least, is this project. So this is a LEED project. OSU, though, has come out with their own sustainability program, which is, essentially a way to assess and evaluate and accredit green building efforts. So it starts in the design process and continues throughout construction. One of the biggest parts of that is the building envelope. So that's really like the skin. And ultimately, the goals of this building envelope system is you're reducing moisture infiltration and heat loss. So the heat loss is for efficiency, obviously, and the moisture is you're trying to make sure that you're maintaining a constantly healthy human environment by preventing mold. So that's really a lot of the goals of something like this moisture board. And over top of this, they'll actually apply a fluid-applied air barrier, and it's this very rubbery substance that essentially waterproofs every single part of this building. So that's what we have coming up. Kind of hit our big structural milestones for the moment, so it's really just rocking and rolling on the inside.
Regarding the you have that OSU has that utility project. I guess I'm trying to figure out how to phrase the question best, but you said you have to set up like your utilities in sort of a temporary fashion until they
Yes.
get that power plant done? Are you guys going to be the ones that'll tie this building back in with the new power plant or whatever they're calling it?
Yeah, so that's a really good question, actually. That was a meeting that we had to have. We are not going to be the ones tying it in. It will likely be NG, which is who OSU has hired out all of their utilities. But your question is also valid across the lifespan of it, is are we maintaining this until they do that? You know, this is the system we've built. Are we supposed to maintain it after we're gone before they tie in? That was a pretty heavy discussion that we had to have with OSU to make sure that we're understanding, you know, are we handing over an incomplete system? Are we the ones completing it? Ultimately landed on no. That was part of why we did the nitrogen fill, so that we can pretty safely say this can be not touched and be okay for 2 years or so. So that was kind of our solution in saying that this we can't own this if it's not going to be completed during our project span. So yeah, great question. I mean, that scope gap or overlap is really relevant, especially at OSU, because NG is not actually allowed to perform any work inside of a construction fence. So they maintain all of OSU's utilities, but they're not allowed to be involved in the construction process. So that's been pretty tricky as well with some of their electrical requirements, because they'll mandate this is what you need to have, and we'll say, great, can you install it? And they'll say, we want to, but we can't. So we've had to coordinate with them pretty directly to make sure that we're understanding where we stop and where they start. And that was one of them. Any other questions? Those are good ones.
This is more of just like directed to you. Is there a reason that you knew you wanted to go into construction when you went civil?
So I, in high school, knew I wanted to do engineering. I like math, I like science, but I didn't really have a particular draw to any of them. And then I went to visit a project site with one of my friend's parents, and we visited with the engineer first, the project engineer, and then went out to the job site. And to go from this person talking about owning every single detail, looking at on paper, all of this, just this wealth of knowledge, and then to actually go and see it in person was just, I mean, there's nothing like it. To be so invested in something that's hypothetical for so long, and then to see it as it goes up and be a part of managing that process to be safe and efficient. I did a little bit of estimating. I've done the other stuff. I've done some design, and I will say there is nothing like seeing your work in person. It is extremely rewarding. There's really no, in my opinion, better way to understand what you're designing than to see it being built, because you can design a million things that would be great as an end product, but to understand the process and the sequencing, that's really where I think I've learned the most, is throughout working in construction and then putting that back into context of reinforced concrete design. So I knew pretty early, my first internship, I was like, yep, this is it. And civil engineering was more like a conduit for that. I do use my civil knowledge, definitely. But what I really feel like I use the most of is just like the general engineering curriculum, you know, like the transfer of force for that beam over there, you know, that's from, you know, statics. So it's, bless you. So I think a lot of it for me is I like that I'm using this like whole encompassing engineering degree as a problem solver, not just as, you know, a very specific subset of it, because, you know, I get bored pretty easily. And this is a great way for, you know, to constantly be challenged and learning.
How have you felt your work-life balance has been these last 6 months?
So another good question. I would say we're right in the middle of summer. This is a pretty heavy construction season. I would say my work-life balance has leaned a lot more towards work. Part of that is we did have some COVID impacts. It did really shift what we were able to do sequencing. So my other project was supposed to finish a lot earlier than it did, but we had to extend the project. So the overlap was a lot stronger than it really was designed to be. So I will say, I mean, that was tough, but it was very much so trial by fire, and I have learned more in the last 2 months than I could have imagined. What I will say is I really like the flexibility. I can't really speak to other workplaces, but with Elford, I mean, you know, there are days where I go home and I work for 3 hours because that makes sense for me. And there are days that I need to leave early and not touch work for 24 hours. So I think one thing that's really important is picking a company that has the right culture. You know, maybe there are times of the year or times where you're working a lot more than maybe you'd like, but understanding that there's a culture that goes along with that can support it in a different way. So I've been working, you know, a lot, I would say, which is pretty normal for starting full time, even though I've worked here for a while, but it's never felt like an off balance, if that makes sense. And a lot of that's just my coworkers and the culture, the people I'm around here.
I guess so. Regarding Elford as like a structure, so you said you had time in your estimating department before. Was that with Elford, or does Elford have their
So
operation set up so that you estimate a project and then you go out and you construct it?
So Elford does have their own estimating department. So we work with them throughout the pre-construction project process, and then they kind of hand it off to us. I worked in estimating for highway, so for Kokosing. So a little different setup. So I actually haven't done any estimating in vertical construction, but you know, my project manager actually, he started out at Elford in estimating and actually transitioned to project management and operations. And I mean, that has informed so much of his knowledge because he understands a lot of what leads up to way before we're putting steel up. So we have a really strong estimating department. I feel like our overlap with them in the project handoff, when they say, okay, we're done estimating, you start building, I feel like that's been really strong. And, you know, the time that I was graduating allowed me to be a part of that process in a way that I wasn't before. So we do have our own estimating department. I think it's, I'm sure if I had started there, I'd probably have a not quite as steep of a learning curve as I did for a while. So I do think that's really valuable. So if you do have an opportunity to intern in estimating, if you're interested in construction, I highly recommend it. Whether or not it's what you want to do forever, that is the best place to get fundamental understanding of what's going on. Any other questions?
I just want to say that this has been wonderful, and I really appreciate you guys giving us your time like that. This was quite.
I was going to do a little outro, Bradley. You stole it from me. No, it's okay. I'm glad you feel so strongly, Bradley, to jump in and say that, because I also feel like this has been fantastic.
Moved.
More than what I had hoped for. It was great. Keenan, great camera work. I know we didn't get to see much of you, but you're behind the scenes. You're the reason we could see Allie and hear her. So good job with that. And and Allie, clearly they've picked the right person for the job here, because you seem very passionate. Clearly, you're very knowledgeable. A lot of good anecdotes here about the project and everything that's going on. It's just, this has been great. So thank you.
Well, thanks for giving us the opportunity. I'll talk all day about what I do all day. So I appreciate it. And Dan, I'll give you my contact info to pass along so that if anyone has any follow-up questions about Elford, about this project, or just construction and civil engineering in general, I would love to do that, be a resource. So